Hello everyone, I am Dr. Mohit. In today's video, I am going to explain something very important and sometimes confusing for students. How to show limit does not exist using epsilon delta definition. Means limit of any function as x tending to x naught is not equal to L. Let's recall the precise definition of a limit. We say limit of a function fx is L as x tends to x naught if for every epsilon greater than 0 means no matter how close we want function to L, that is, we can choose any distance epsilon around L, epsilon distance above and below L. There exists a delta greater than 0. Here delta tells us how close x should be to x naught. There exists a delta means we can always find a small enough distance delta around x naught. Delta distance to left and right of x naught such that whenever x lies within delta distance around x naught but not equal to x naught, the value of function fx lies within epsilon distance around L. So in mathematical form, we can say that this delta inequality implies epsilon inequality. In words, whenever x is close enough to x naught, fx stays close enough to L. This is the formal definition of the limit. Now look at the right side of this table. Uh, when the limit of function does not exist means it is not equal to some certain value L. So here we reverse the logic of the first case. Okay. So instead of saying for all epsilon, now we say there exists an epsilon greater than 0. It means there is at least one fixed distance epsilon around L. Then now here we say there exists a delta greater than 0. So instead of saying there exists a delta greater than 0, we say there exists means we say for all delta greater than 0 means no matter how small delta we choose, or we can say that for all delta distance around x naught. Now what happens? There exists an x greater than 0 satisfying this delta inequality. Means there will be always at least one x within delta distance around x naught such that fx will not be within epsilon distance around L. So we can say that for some x, this delta inequality implies this epsilon inequality. So in the first case, we can always trap function value fx inside epsilon band around L by choosing delta small enough. But in second case, no matter how small delta is, the fx goes out of the epsilon band. That's the logical opposite. Now question is how to show that a limit does not exist graphically. See the figure. Let us consider some function y equal to fx here. This is the graph of the function. We need to show that limit of function is not L, a certain value, as x approaches to x naught. If we choose this epsilon here, then for this epsilon, we can create this yellow epsilon band, which is from L minus epsilon to L plus epsilon. For this yellow band, we determine the symmetric blue delta band, which is from L x naught minus delta to x naught plus delta, for values of x. So you can see here that for every x, for every x here, x is not equal to x naught, the corresponding function values lie inside this yellow band. Okay, so we can say that for this given epsilon, there exists a corresponding delta here. Okay, now look at this bottom figure. In this figure, we choose a smaller epsilon than previous one. This is epsilon. So for this epsilon, we create this yellow band, epsilon band, and determine corresponding delta band. See here, there is a point x1 which is inside this delta band, and for this x1 function value is fx1, this value. Okay, and you can see here that this function value is outside of this yellow band, outside of this epsilon band, means fx1 is less than L minus epsilon. Okay, so we can say that for this epsilon, for this chosen epsilon, this delta does not work, means even x1 is very close to x naught, but fx1 is not close to L at all. Okay, now see this figure now, third figure. So here in this figure, we again choose the same epsilon. Okay, same epsilon as chosen in this figure. So same epsilon we choose, but we choose smaller delta. Okay, but we choose smaller delta, means same epsilon in both figures, but smaller delta here in this figure. So we see that what happens now. So for this smaller delta, still there is a point x1 for which function value is fx1, and this function value fx1 is outside the epsilon band. Okay, so in this example, we see that for the given epsilon, no matter how small delta we choose around x naught, means here for some fixed epsilon, we choose smaller and smaller delta so that x values stays very close to x naught, and function value also could be within delta, within epsilon band. But we can always find some points x1 for which function value jumps outside this yellow epsilon band. So this is the case when we say limit does not exist or is not equal to some certain value L. And why this happens? This is because of jump of the function value at x naught due to this jump. Let's discuss one real example here. Given function is a piecewise function which is x for x less than 1 and it is x plus 1 for x greater than 1, and we want to show that limit of this function is not equal to 2 as x approaches to 1. See the graph here. As x tends to 1 from left, function approaches to value 1. As x tends to 1 from right, function approaches to value 2. So left hand limit is 1 here and right hand limit is 2. Since left hand limit is not equal to right hand limit, therefore we say limit at x equal to 1 does not exist. Now how to show it using epsilon delta definition. Suppose we choose epsilon is 1 by 2, a fixed value. For this epsilon band will be L minus epsilon to L plus epsilon, which is 2 minus 1 by 2, 2 plus 1 by 2. So it is 3 by 2 to 5 by 2. So this is epsilon band. See, for this epsilon is 1 by 2. If we choose delta is 1 by 2, then delta band for x is delta band is 1 minus 1 by 2, 1 plus 1 by 2. So it is 1 by 2 to 3 by 2. So you can see that here there is an x naught which is 2 by 3, for which function value is fx naught is also 2 by 3, and this 2 by 3 value is less than 3 by 2. Means we can say that this function value fx naught is not in the epsilon range or epsilon band. Okay, so now choosing delta more smaller. Okay, suppose delta is 1 by 4. Okay, it is more smaller range for x values we find here now. So delta range is here now. It is 1 minus 1 by 4 to 1 plus 1 by 4, which is 3 by 4 to 5 by 4. So for this delta also, for this delta range also, we are getting an x naught, which is 7 by 8, and for this x naught function value is also 7 by 8, which is less than 3 by 2. Means we you can see here that this function value also is not within epsilon range. So no matter what delta we choose, either this one or this one, okay, there will be always an x naught within delta band, for which function value fx will not be in the epsilon range or epsilon band. Hence, limit as extending to 1 is not equal to 2. Limit of function is not 2 as extending to 1. So that's all for it for today's lecture. How to show that limit does not exist using epsilon delta definition. If you found this video helpful, please like the video, subscribe to my channel and share. Thanks for watching. See you in the next one. Thank you.